Good morning.
Good morning.
Morning, sir.
Okay. As we've seen, what is on the study master is a review, because I'm receiving messages from you guys that I know you haven't heard this, so that's the reason why we are doing what we're doing today, which is simply to review, especially the Cartesian plane, because that's where the complaint is coming from. So let me share the screen. So that's the screen there. I actually found this somewhere. So in fact, the beauty is that this one even has a velocity vector. So this is the screen. I don't know if the font is very big because some of you are using phones. But then we have a vector there in red, and it's written as V there. This is better than writing the number at the end. So when you write it as V there, then now you look at what components. The components Vx and Vy of the velocity V. So Vx is the horizontal. This line in the horizontal line is Vx. So you go in the x. Then the line in the vertical, this is Vy. So x is horizontal and y is vertical. I loved this this handout, this tutorial thing that I was getting this from, because they even use the SOHCAHTOA. So the angle there is 90 degrees, except for them the angle is phi. So now this they use the SOHCAHTOA to say the relationship between Vx and the V, which is a vector. So Vx over V is cos theta. So what is cos phi? So the adjacent is Vx and the hypotenuse is V. So that's the case. Also, Vy over V is sine theta, meaning sine phi is opposite over hypotenuse. So that's what we get when we say Vx equals V cos phi and Vy equals V sine phi. That's all. So in this quadrant, that is the only reasoning. What I actually told you the last time was that if the angle is not here, so I wanted to highlight, if the angle is not here and it finds itself there, We'll look at that as well. This one actually completes. So there where you've said cos, you just interchange the sine and the cos. That's all. Why? Because this one now is also Vx. You can draw a line there. It's also Vx. That line, this angle, that one will be opposite. So there where I've said cos, you say sine. Where you've said this sine, you say cos. If the angle is with the vertical axis. So that's the reasoning. Well, let me move to, they've moved to the second quadrant. And have you seen how they've put the angle them for the second quadrant? The angle is coming from this east line going there. That's the angle. Go to one way, so you can use that if you want. But then me, I just opt to love to use this same one. So guys, let's do, if anyone has a calculator, what is sine 30? What is sine 30? If anyone has a calculator there, what is
0.5.
0.5? So Crispin, yes. Do 180 minus 30.
150.
150. What is sine 150?
0.5.
It's also 0.5. So the sine of this angle there, because how do you get this angle? You say 180 minus theta. The sine of this angle there and the sine of the angle inside there are the same. So now, let's do cos 30. Say, okay, minus cos 30. Minus cos 30. Negative cos 30. What is it? Who was
it's neg 0.8687 to
866,
2 decimal points. Yes.
0.866, Stephen.
Yes.
Okay. So now do cos 150.
It's the same neg 0.6866.
866. So now, why have I put a negative myself when I was using this angle? Why? Because the x is going to the east, to the west. While the y is going up. Remember, up is positive, but to go left is negative. So that's why you heard I said negative, negative cos 30. Because the cosine component here, going here, the horizontal here, it's going west. So that's the reasoning. But if you use this angle from the east, going there, if you use that angle, what you actually get is the negative value without doing anything much. So now, if we move in the third quadrant, what you will realize is that the Vx is negative, while it was going to the west. The Vy is also negative because it's going down. So how do we get that angle? We'll say 180 plus, because 180 is from here to there, it's 180. Then we'll add plus the angle there. So now we are using Kt, which is a special angle. So what is 180 plus 30? 180 plus 30. Nakumu Dr. was
210.
210. So my friend Crispin, what is sine 210?
Neg 0.5.
minus 0.5. Have you seen that all of them is 0.5 and 0.866? Eh? But what is changing is just either negative or positive. How about cos 210? How about cos 210?
Negative 0.866.
Negative 0.866. So that is the case. So when you come now to this, so it means for this, that's the reason why every time when I'm just using 30, I'll say minus v cos 30 minus v sin 30, because I know that the actual angle from the anti-clockwise, from the east going anti-clockwise, is actually it will actually give me a negative. So the reasoning is you just look at this, you see it's going west, and so it's going down. For the fourth quadrant, it's the same thing. You will say, because this is going all the way almost up to the end. So you say 360 minus 30 minus theta. So we're using 30 just for illustrations. What is 360 minus 30? 360 minus 30. Mwena aberesha calculator, guys. No mutu mune ubom. Chakova mutuli
330.
330, yeah? So my friend Crispin again, what is sine 330?
Negative 0.5.
Negative 0.5. Have you seen that the sine component, which is the y, is going down? That's why it's negative, isn't it? It's going down. So here, if you're just using the 30 inside there, you have to indicate a negative. Why? Because it's going down. Then this one, how about cos 330?
0.866.
Positive. It's positive. Is it positive? Guys, suminen. Is it positive, guys? So when you look at this, when you look at this, the x is going to the right, which is positive, while the y is going down. So if you're using the angle there as theta, when you're writing the vy, you must indicate a negative. But when you're doing the vx, you just leave it as positive, because you can actually see that vx is positive while vy is negative. The relationship between v and that I've already explained is the are we back, guys? Yachitanan trip. Yachita trip net internet. We are back, all of us. My internet tripped. Okay. So now when we are here, we find the relationships. I was saying use Pythagoras theorem as the relationship between v, which is the hypotenuse, the adjacent, and the opposite. So you actually get v squared equals vx squared plus vy squared. So to get your vector, you always do square root. That's how you change the subject to the formula. Square root of vx squared plus vy squared. Then we actually also established that vy over vx is actually tan phi. Tan phi. So to get phi, you do what is called the tan inverse or arctan vy over vx. So that's the reasoning. These are the simple concepts, but then we needed time to go through just one, especially if in So I'll create, let's read this question here. Guys, any question up. Find the magnitude and direction. Read this from your none. And guys, anyone to read this question? Friends. Robert.
The question reads,
Okay.
Yes.
the magnet of the resultant of the three
Boy, taide
vectors.
umfika na mpano no voice yo bega. Mwaza mte ojina bena na wewe. Crispin, raise your hand.
No,
You raise your hand.
find the magnitude.
Okay, find the magnitude.
I can read it, right?
You have seen that your friend in internet is night and Chuaberenga.
Yes.
Yeah.
The question reads: find the magnitude and direction of resultant of the three displacement vectors.
Okay.
Vector A, which is equal to 75 meters, 30 degrees north of east.
Yes.
Vector B, which is equal to 60 meters, 71 degrees west of north. And vector C, which is equal to 90 meters, 27 degrees south of east.
So you must put utma comma between the vector and the angles. I forgot that. So now let's want to look at the solution for this. So this is how you draw the vector. The first one we said 30 degrees, it was 75 meters, 30 degrees north of east. Remember, this is the north, south, east, west. I'm not very elaborate in Shibiki, the north Munja. It's like I've trusted that you already know where north is, where south is, and all. Then the B is 60 meters, 71 degrees west of north. Is it? 71 degrees west of north. Then the third vector. Have you seen where of north? Nali londolola guys na londolo kutira of. Going forward that of north, it means the vector is drawn from the north line going to wherever. So since we've been told that west of north, so starting from the north, going west, which is to the left. The last one is 90 meters, then 27 degrees south of east. South of east. That's how you go about it. So don't ukuchula iyo. Then we said we are from explaining that there's X and Y all the time. X and Y. So ngoli no mwenso, the first thing you do is here where there's 71 wasanga ka difference. I think it's 19. You find 19 here. You put it here. So where there's X here, everywhere you do cos. But then we are mathematicians, we should not always be careful. We can even be using all the trig functions. I've already told you that when two angles add up to 90, the sine of one is equal to the cos of the other one. So now, for the first vector, it's in the first quadrant. These are both positive. That's the reason why I've written 75 cos 30 as x. Why cos? Because the angle is with horizontal. If the angle is with horizontal, the x is the cosine component. Guys, the internet is letting me down. Kamai Fayaka. If the angle is with the horizontal, the x is always the cosine component, while the y is the sine component. That's why I've said 75 cos 30. Simply that. Why? Because remember we drew the diagram here. The x is adjacent while the y is opposite to that angle. Then for the y-axis there, you say 75 sine 30. Those are the values. Now, if the angle is with the vertical, if the angle is with the vertical, for this quadrant, remember that x is negative, it's going to the west, while y is positive, it's going up. So for the x, why am I using sine? Because the angle is drawn from the north going south line. If the angle is drawn on this line, there on x, for the x component, you use sine. Then for the y component, you use cos. That's the reason why I've written minus 60 sine 71 and plus 60 cos 71. That's the way it is. This one again now is with the horizontal. Iponene, pamu line was straight. Uyum line was straight. Uyuli apa. Then nga ulipadi uyum line was straight uli. Ule sonta kumulu na panshi. Twala wonfya if puseneko. But uyum line uli straight. Nga pamusebo uyu. So that's the reason why there we have used cos again. So you've seen cos 27, 90 cos 27. Why is it positive? You remember this one is positive because going east, the x, while the y is going down. Y idi hapa so hapa ndipo shakana nika case. So that's the way it is. So when you find these values, you find them, you can just proofread if what is accepted there is a, because the explanation is very accurate. Na siaka demba mulubiro. So tumasanga chilimbi. Wasa apa kutininka course, but tininka sign. But this is what you actually do. So when you get this value, this value, this value, you add them. When you add these values, this, you get this one. This, that, you get this one. So our resultant vector will be 88.41i plus 16.17j, like that. If we were to draw the resultant vector, it will look like that because both of them are positive. Because both of them are positive. I think I've drawn differently. So the only thing which is accurate here is there. So I'll send you the actual thing because the x should be very big so that it fits the swap. So the drawing should have 88.17 there. So I'll redo it and then I'll resend. But this is actually accurate. But when you're getting your angle, because it's y over x, the angle is y over x, the angle is actually accurate. What I've done there is this one. The only thing that I've messed up is like a drawing here. I've messed up the drawing, forgive me. The x-axis is the one which is 88.14 and the y-axis is 16.17. Because some of you will be like, no, basa the mistake you ain't much panga in after just I had that mistake, na brain you say komeka. Those are the things that we hear. But actually all the answers here are correct. The only thing which is wrong is the diagram. So the angle is y over x. Why am I sure? This is my y, so it's the one who should have been there, and this is my x, it's the one who should have been there. So these are the things that are there. So when you solve tan inverse y over x, it will be tan inverse open brackets 16.17 divide 88.14 cross brackets equals, I've told you that angles you always round off to 1 decimal point. So I'll redo this diagram, guys. Nyapene fikonse fe nalaka lemba buno bueno. nalabula fya kena kapepa nalafuta fya pakaina mwisho file stick. Then inka draw again. Then I'll resend. Are there any questions? Then when you're reporting, you say 10.4 degrees north of east. Are there any questions, guys? Friends? Because I think Nindondora wino. Nindondora wino sana. Junior Tembo, Stephen.
Yes, sir. I think I need a little bit of clarity on where to, like when something the sine and the cos, like when there's 71 degrees angle.
Yes, I've already explained there.
On top there.
Like if you
Yes,
want to
like,
get 19 here
okay.
with horizontal, because cos 19 is actually the same as sine 71. But then the explanation there is that for this 71 angle, it's drawn from the vertical line. In most cases, the lines are drawn from the horizontal line. So if it's drawn from the vertical line, therefore x you say sine, and for y you say cos. I think I've already been singing about this by saying if two angles add up to 90, the sine of one is equal to the cosine of the other one. Why? Because if you finish the triangle starting from the top, wapuisha kuso triangle, wapanga limbi akabokosa hapa. This side is equal to that side, and this side is always equal to that side. So you look at this one now, which one, the one which is opposite upper becomes the adjacent the other way for this angle. But then the simplest thing is just to remember that if the angle is drawn from the vertical line, x is sine, while y is cos. That's all. But in go there for women, about my uniformity, like kwa wakwata that disorder there for it finfite moneka same inshiwe kubura fyango wabura 19 yapa. So ati ukukonso ukukora fyama cos no kwama sine. Why? Because your angles then would have been with the horizontal. If the angles are with the horizontal, x is cos while y is sine. While if the angle is with the vertical, x is sine while y is cos. Are there any questions? Have I tried, Mr. Tembo?
Yes, sir. I think I've understood. And so when getting these geometric functions, say cos is negative here, cos is negative there. So should we always rely on the all students take chemistry?
No. The all students take chemistry can only apply. Could actually so vanani a crispin, but a crispin. Remember that time? I was bothering crispin a lot. That one, that's where the all students take chemistry applies. But upper, just look at the directions on the vector diagram. You will say E75 up. The x is going east, which is positive. The y is going up, which is also positive. So these two are both positive. But in Gatwaisapa, the x is going west. So nishpadi x y shbati ni negative. While the y is going up. Y shbati up ni positive. So that's why apapadi negative, apapadi positive. Then for this one, the x is going east, which is positive. X is horizontal. While the y is going down, which is negative. That's why here there's positive and there's negative. Mr. Tembo, you ask like a teacher. You have a background there teaching.
Really, sir. I was just going through these things yesterday, and I think I had a little bit of, I had most of the trouble.
Is it helping what I'm trying to explain here?
Yeah, it's helping, sir. It's helping.
Okay. Anyone, guys, especially Banamayo. Palina ujana ni monga, alikuwa laki monga. Pastor Dimas na vacha help me, sir. He said, "Ja help us." Mr. Monga is help us. Be a team player. Not help me, sir. I'm moving man that I'm guys been about vela in the no. All of you move at the same pace. That's why I wanted you to have. You can even have your own tutorial as a group. You can even be doing Zoom as a group. So, like if you already have the Zoom host meetings, mom peratle all the host meeting you. Alat pishamo fionse for baron the red wasa. Then mwambo kutarikana kuna kwene. That's where you'll be open channel. Any question, guys? We have 7 minutes, which is a lot. Which is a lot. Pyrogram law, there was a claim that you have understood a bit on pyrogram law, even with the weights. Just go through the notes that are there. Zamto have let me down today. I'm sure my voice has broken at some points. Taidi bwino internet yo. Yachima pono kushima mwachiluba. Any question, guys?
So can you go to the fourth question on the Sedimas there is the first question, which is the fourth question. I had troubles to resolve it for T1.
Okay. This is the one. The first question. Is it first question, Robert? Robert, first question. Or is Stephen? Stephen, is it the first question?
Yes, it's the first question, sir.
Okay. For this one, it was a tension. I'm sure you remember the way it looked. Eh? There was a kawet here, then there were tensions attached to the cylinder. So now for this one was 36. This one was T1, then that one was 5 kg. The first thing I said was convert the 5 kg to weight, because these are weights, these are vectors, they're not scalars. These are vectors that we're doing. So if you have a mass, always convert it to a weight. Don't finish the question. You want to question this over. Yeah, nama kg. Nishpadi parallelogram. Nangpadi ama vectors. Just know I'm doing something wrong. So this 49 is also the tension there. Upward force equals downward force. So T3 is always equal to the weight. T3, or the tension here, it can be called anything. Maybe they can call it T1 if they want, or T what. But the tension here is always equal to the weight. That's why I wrote it direct as 49. Then you finish the parallelogram like this. This is a completed parallelogram. This side will always be parallel to and equal to that. And this side will always be parallel and equal to that. Then these angles, you drop them using alternate. They are making a Z. Napa, they are making a Z. So that's why you have 40 there, 40 there. Theta is also theta there. So if this is 40, Pamuluni 40, but it's not really helping us at this point. That's reasoning, because we cannot really confirm this is a triangle, the right angle triangle property. So we skip that. So now the next thing that is there is that you find the angles inside. Theta, so that's why I wrote 90 minus theta. Then there is 40. What is 90 minus 40? This is 50. The angle here is always equal to the angle there. And the angle there is always equal to the angle there. It's very beautiful when you reason like that. That's all. So what you realize is that if you have the 50 there or the 50 there, then you also have these sides. So the 50 is opposite the T1. Even there, the 50 is opposite the T1. Then you have these sides, 49 and 36 newtons. So you can actually use the cosine rule. That's why we use the cosine rule here. So when you use the cosine rule, you actually establish that T1 is that 37.8. Then to get the angle, after you get the 37.8, because it's the one which is there, opposite the 50. So to get the angle, you use sine rule, because this and this you would have known, and this you know, then you are looking for theta that is there. That's the reason why I wrote it nicely. I loved it like this. Instead of calculator or subtractor, I just wrote it as sine 90 minus theta, because I know that the angle is 90 minus theta over 36 is equal to sine 50 over 37.8. Then I remembered that sine 90 minus theta is always a in the envelope. Sine 90 minus theta is always equal to cos theta. So I wrote now, apart the sine 90 minus theta, I wrote cos theta over 36 equals sine 50 over 37.8. This is sine rule still, but Molina cos. Why? Because of the identity. Then I changed the subject of the formula. This moved this side, here is upper. After here is upper, okay, this one is dividing this side. And remember, multiplication and division are inverses. So if we, on the side of the equation, this one is dividing. If it crosses, it starts to multiply. So that's how I multiplied there and found this. Nganasange number, that's when I did it. Theta is cos inverse of that. That's how we got it. 43.2 degrees. I've explained more below, but very elaborate. Very elaborate. So that's the reasoning. You either use cosine rule and sine rule. That's the only thing that you do. So try to reason like that, guys, with vectors. These are simple concepts which because it's monotonous, like you do the same things over and over again. Like there's no reasoning. There is very little reasoning that is there. So try to analyze these things. Take care of yourselves and enjoy your weekend. Why am I saying bye and not asking you to ask questions? I'm only remaining with 1 minute.